Okay, so we want to know if we can use the integral test on this one. And so let's think about this. Let's break this down and see if we can actually apply the integral test. So we have in the numerator cosine of pi of n. And this is a series. So with a series, we plug in values starting at whatever we have here. So our first term that we would plug in for n would be 1. The next term we would plug in would be 2, then 3, then 4, and so on. That's how series works. You're plugging in discrete integers that are increasing towards infinity here. So what is cosine of pi? What would that represent? Well, let's remember the unit circle. So we have a unit circle, and then over here we have the value 1, 0, right there. And over here we have the value -1, 0. And so this right here is pi radius, and this is 2 pi, or 0 radius, and all multiples of them. So, as we can see, this thing is going to alternate between 1 and -1. Because when we plug in 1, we get cosine of pi. Cosine of pi is -1. Then we plug in 2. That's going to give us cosine of 2 pi. That's going to be 1. Then we're going to plug in 3. That's going to bring us here. Then we're going to plug in 4. That's going to bring us here. So it's just going to be -1, 1, -1, -1, 1, and so on, right? It's just going to be blinking between negative and positive. And so already it doesn't satisfy our integral test condition. We don't even have to look at it anymore. Because for our integral test, we need two things. We need that all its terms are always not negative, and we also have to make sure that it's always decreasing. In our case, it was going to be decreasing because we're plugging larger and larger values here in the denominator. That means the term as a whole is going to be decreasing, but it's too late to rescue it. You can't do the integral test because this is going to blink between negative and positive.